Hi, John. As you know, I think I may have damaged my fruit jam, which I'm very sad about.
No,
It gets real hot. It doesn't work.
that's okay. That's fine.
I was playing around with speakers the last 24 hours, and that's been bad news.
Yeah.
Uh, but what I was doing before that is I was really digging into performance of CircuitPython and FruitJam. As you were testing, you found some hitches, and I'm excited to dig into that a little bit. Hopefully,
Great.
they're fixed. But one thing I was doing, if you show my window, is I took a video capture of the output of the boot animation that we've created, that Foamy guy coded up, and I've split each individual frame out so I can, I think I can step through it and see what every frame as captured by the capture card is.
Mm-hmm.
And it's interesting to see how display IO is rendering. For example, here's an interesting frame where it's updated part of it and not the other part of the frame. Because
Weird.
there's right now there's no synchronization between when display IO updates the frame buffer and when it gets spit out to the actual display. Or, and so you get artifacts like this. If you're overlapping in the middle, you can see like, oh, the next frame looks okay.
So the buffer isn't full yet, and it got displayed.
Right. So the way that the DVI output is there's this big buffer that like is the picture, right? And it's just looping over that, spitting it out at whatever frame rate we want to update, and then display IO is trying to update at a different, also at a different frequency, at the same frequency, but often if it slows down, it doesn't always do that perfectly.
They're not locked.
Yeah,
together.
they're not locked. So that's why we're seeing artifacts like this. And then here you can actually see that like the apple or the fruit has shifted. The top part of the fruit shifted.
Yep.
And you can see artifacts of also like how display IO is doing the updates. So like each of the letters is a separate tile grid, and they kind of get moved independently, and their dirty areas get like updated separately too. But it actually looks quite good. I should say.
Yeah, you're the end result still looks good. Yeah, but it's
Yeah, like this is like 60 frames a second. So like any glitch like this, you
not
might
seeing. Yeah.
perceive, but you're not really going to see it. So it looks pretty good. I was actually surprised because when I was testing it, I had it slowed down to 10 frames a second. I was like, oh, it's so slow. And then I was like, oh wait, let me do it at 70, and it like looks quite good.
Oh, that's nice. Yeah.
The one thing that I was going to look at, and then we're going to get to it, is that there's a color roll, and it's interesting to me how like it's updating slightly different parts of each tile grid in kind of different orders, and then I think I guess it is every single frame. I was thinking that there were frames where it was the same. This one's particularly interesting how the A is like split there. And then the yellow does a similar kind of pattern as it goes. So yeah, it's a matter of like display IO internals. But it's still pretty interesting to watch it kind of frame by frame like this.
Yeah, the color roll actually looks pretty consistent.
Yeah, and like the
kind of fills the top, and then everyone but the last letter, and like the M,
right,
and the M.
Right. And then it ends up green. So yeah, the audio does play back with this, which is great. And I've been testing with your demo as well, and just was a little disappointed that. Well, I'll have to look and see the example that you were doing. You're definitely stress testing it.
Yeah. Note on every eighth note, just see if it can.
Yeah.
Keep up.
You just clicked it, right? Like I was gonna see if I could add some code to just fill it.
That was my thought. It would be so much more convenient to have like a demo mode where you can populate some notes, because it's actually quite annoying to go in and click.
Yeah, but then again, like maybe you had an earlier bug where it was like, if I wiggle the mouse, this happens more often, and like there's all this underlying machinery that is happening that you may actually need to do the test.
To test with the mouse, If people don't know what we're talking about, by the way, this was the sort of Mario Paint music program I had shown a couple weeks ago, and Scott's been helping me with making
it's like
Python happy on the Fruit Jam.
Yeah, I'm really happy that we fixed the like all the squeaks and squawks that were happening when it loaded.
Yeah.
That's been really nice.
Yeah.
It turns out we were playing random memory. Oops.
It's funny because the sound of the random memory is similar to when you used to get a cell phone too close to a set of powered speakers. It kind of had that really horrible sound. Kind of stuff.
Yeah, so that should be fixed. I'm excited about that, and then we'll see.
That's great. And what are you using for capture to do the?
So I got an XR1 Lite for $60 off Amazon, but it looks like that's like kind of the last of them.
Oh.
Because both Amazon and Newegg are now out of stock. Which is kind of a bummer because for $60 they were a good deal.
Yeah.
Mainly I was trying to use the $20 one off the shop, but it's USB 2.0, and I think because it's 2.0, it just doesn't have the bandwidth really to do a good capture. So the XR1 Lite was recommended by some 5-year-old streamer capture YouTubers, and for $60 I was like, sure. And
it looks like it got a nice quality capture. That looks pretty crisp.
Yeah. So this is CircuitPython outputting at the 720 by 400 resolution, and then I think it is actually upscaling it to 1920 by 1080 for the capture.
Cool.
So
excellent. Well, thanks for all of this work.
Yeah, and I should say that I'm deep diving on Friday, 2 p.m. Pacific, and it's the last one I'm going to do for a while because I'm going to be on part-time/leave as I watch my youngest before she goes to daycare.
Right.
But Tim will be keeping the deep dive tradition alive as he always has been. Did for my first paternity leave too.
Yes.
So,
good. Congratulations, and good luck with all that.
So thanks to Tim for filling in on that for me as well.
Excellent. Well, thank you so much for the updates,
Thanks
and
for
we'll
hosting.
see you soon. All right. Okay, very cool stuff. Let's see. Next up, we've got Liz with a interesting looking gizmo. What is going on, Liz?
Hey, so I'm working on a camera slider project with Noe. So this is going to be kind of the new version, and it's using the TMC2209 stepper motor drivers. And what's really cool about those is you can use them over UART. So I have 2 of them on this helper PCB that I'm communicating with UART with the KB2040 that's soldered to the back. And by doing that, that means we can do things like track position and stuff like that. So I can just show like basic functionality that's locked in right now. We have this rotary encoder and a TFT that's connected over SPI, and you press to begin. And then there's 2 end stop buttons on either side that's going to control the path for the motor that's actually sliding the camera on the rails. And so to choose where the motor is starting, you'll hit it with the end stop. So I'll just press this one on the side here. And then for motor 2, which is this right here, which our cat is helping as a model, the idea is the camera would pan, and you'd be able to have it select the start and stop position. So to start, I'll do this position here, but then I'll move it to the end with the rotary encoder. And you can see our motor is moving. And I'll put it here. And then it's going to move to the original start position. So then when the time lapse starts, it will know that, okay, you're going to want to go to that position. I'm at the start, and it will be able to go through there. And so now I'm just going through and testing different time-lapse modes. There's also going to be kind of a one-shot mode where you can get like a fast shot, medium, slow. And we designed this carrier PCB just because there are a lot of components, and I have a blank one here. So we've got the KB2040, 2 resistors for the UART line, and then terminal blocks for power. We've got an NPM 3601, which lets us do the 12-volt power for the motors, and then convert it to 5 volts to power the KB2040. And then the 2 end stop connectors, and then on the front here, rotary encoder, TFT display, and emoji art courtesy of the Adafruit penguin script, which
that's great.
A lot. So
that's really cool. And so this will be a dolly for the camera to move, and it's got a panning head on it. So
and
you've got 2 axes that you can
exactly. And because they're both connected over UART, they can both be controlled independently. So you can have one motor doing one thing and the other one doing another. So
That's great. And then you'll just be able to mount any camera you want and put it into its own
Yeah,
little
yeah.
time-lapse
No, it's
video
got
mode.
a nice solid mount here that the camera can sit on.
Yeah. Oh, that's great. This is what, V4 of
I think
the
so. Yeah.
ongoing camera slider upgrade?
Yes.
That's great.
Yeah.
This is advanced. Well, I love that you've put a board together to make the connections dead simple rather than the unimaginable breadboard or proto board wiring.
Yeah, as we were doing the first thing, we were like, this is getting really out of hand.
So much wiring.
Yeah.
Really cool. Yeah, neat UI.
Yeah, so next week or two, you should see it on Learn, and people will be able to build their own.
I think it's time. I built, I think, a V1, and I think it's time to try the V4.
Yeah.
Awesome. Well, thank you, Liz. Really great stuff. Appreciate the update. All right. Very cool. Okay, let's see. Next up, we've got David, who I think we've got this week. Hello, David. Hey.
I'm here. Okay, so it's the middle of the night here in Belgium, but I'm going to show you something to control the charging of my electric vehicle based on the solar availability and how much my solar panels are producing. So I'm using a tool which is called evcc, and it's got a nice web page and control panels and everything, but I wanted to display that on a PyPortal. So that's the image you see there. And so I had a lot of different tricks. The information is coming from MQTT because evcc is storing all of the info about the current situation. I'm going to start charging the car to see if you see the effect. So on the top bar is showing you how much is coming from the sun, which is 0, and how much is coming from the network. And then on the bar below, I can have 3 information. So it's a progress bar, but with 3 values. And I can have the host consuming electricity. Currently, that's what's happening. And I can have the car consuming electricity. And then sometimes I send electricity to the network. And then the bar below tell me about the charging level of the car. It's not starting. Maybe I'm going to cheat and use the Tesla app to do that. And I've got so it's showing me how much is currently in the battery, what is the limit. So this is a 3-color progress bar. So I can control that slider to say, go to that maximum value. And you see you've got the full green, that's what's in the car. This is what I want to put, and this is not going to be used. And you already see you have the 2 colors. So the house is taking 481 watts, and the car is taking 1,200 watts. So that's rather slow charging, but okay. So yeah, so with this screen, I can see almost real time what is going on. Is it charging? Do I have sun? The voltage, because sometimes it's go too high and the solar panel will just disconnect. So yeah.
That's really cool. And this is PyPortal. And is this Circuit Python or Arduino using?
Yeah, so it's Circuit Python. I'm not using the PyPortal library. I'm just using display.io stuff because I want to be able to move the code to other piece of hardware.
Yeah.
So, but that was the easiest hardware for doing this kind of stuff.
Really nice. Yeah, it looks great.
I think I need to do playground article because there are a lot of tricks into that. I've tried to make my life easy. So because I've got the MQTT variable, but then I want to have easy to use variable to display that on screen. And I want to use the F string so that I can say I want this word and this value put together. But the F string are occurring immediately, and I wanted to postpone that until the time I want to display the value. So I had to find all kind of trick.
Okay. Yeah, please share those tricks on Playground. I think people would appreciate that.
So yeah, that's my project, and maybe I'm gonna display in under circle stuff. I want to do a sun that goes bigger and bigger when there is
Cool.
more sun,
Yeah.
and use that circular stuff to
Mhm.
display the same kind of information.
Nice. Oh, I love it. Thank you, David. Appreciate you staying up late.
Yeah, it's late.
All right, thank you so much. We'll hopefully you can bring it on again to show us any changes or updates.
Okay, see you soon.
Thank you. Bye bye. All right, really cool stuff. Let's see. Next up, we have TA. Add this display. Hello, TA.
Hello. So it's in the morning here in Vietnam, and I just want to show off some of my school projects.
Yeah.
So I put together a development board for the STM32. This is for the development board, and the main case is still it can be used as a development board, but it has like a robotics applications. So I've got in here the buck converters here, so you can have the high voltage input power here, and then you can have the 5-volt rails. After that, you can have the 3.3 volts that power the microcontrollers. And I have some peripheral here, so you can have the inertial measurement unit. So I have the 9-axis inertial measurement unit here. I have some LED arrays, and I have like force motor drivers. You can hook up like four DC motor here, and you can control them independently, like with the PWM. And then you can combine the channel, like you can combine two channel into one channel for the stepper motors. So these are the drivers from Texas Instrument. And then the cool thing about it is that you can stack up with the like the single port computers, just like this. So the mounting holes here are like the design for the famous Raspberry Pi.
Yeah.
You can have the like the connection to the UART thing. You here, let me see. Here you can have the connection here, and you can have the power cables coming from the bottom, so you can power the single board computer here, just like this. And then
that's a nice looking setup.
Okay, so you can run a robot operating system on the single board computers. So so the host will control the all the high level and the low level. And the best thing about it, you can make it fully autonomous by running the ROS robot operating system. You can have like add some sensors like the lidars or the camera, and you can make it fully autonomous. And it's all in one, so you can have like it's not about the mobile robots. You can do the drones as well. So you have the inertial measurement units and you have the microcontroller. So it's basically everything of the robot. Wow. And okay, so some I think that's it. I think that's right. And I also made a prototype robot. So I can show you here. So
yeah,
this is the differential drive configuration. So you can have you can see it here. So you can have the 2 motors and the batteries are in the bottoms. So you can add the peripheral into the board, just like the normal development board. And you can have the motors wire going here and the power cables. So you can just plug it in and you are ready to go. You are ready with the robots.
Yeah. Oh, that's a great looking system. Really nicely done.
Okay, so it's about the development board itself. So it's kind of small. You can use it, and I'm currently working with the low level drivers and the high level for the robot. So that's a lot of work to do. Right. So
is there anywhere that people can find out more about it? Any links online that we can put into the Discord or share?
I think I can have some pictures about the specification. So
cool.
It's still in the research and development process. So it's my projects.
Nice project. Really great. Thank you for sharing that so much.
All right. Thank you.
Yeah. Please come on back anytime to show us more.
Okay. Thank you.
Right. Thanks. All right. That was super cool. And let's see. Last up, we've got todbot.
Oh,
Hey.
hey.
Hey, I didn't warn you. I started to warn you, and then I just clicked.
Click.
Oh, wake up.
All right, so if you could share my screen. So I've been working on, for the last couple of months, this, what I've been calling a Synthio tutorial. Synthio has changed a bit since I really like was into it a couple of years ago. And so I decided I'm going to kind of go from scratch and reteach everything about what I, like, eliminate all my assumptions about how Synthio works. Synthio is a synth engine for CircuitPython, for those who don't know. And so I've been building this up, and it's got several sections. Oops, I can't click there. I have to click here. It's got several sections, and the getting started section is what you're just looking at, and it goes from, like, you know, how to wire it up, and every bit of code is accompanied by a little video, and each bit of code is fully runnable, so that you can just kind of go. And as you know, I've made many little synthesizers like this one, and this one, and this one, and this one.
You
this
get
one.
a synthesizer, and you get a synthesizer.
And so the whole guide is based off of this breadboard, which is just a Pico and a PCM's 5102 DAC, and a couple of pots and a button. And so you don't have to have any of my little gizmos. You can just make one yourself in like 30 minutes. But the cool thing is that you can just start doing weird little noises, like, hopefully this shows up on the audio.
Yep, I hear it.
Yeah.
Ooh.
Oh, hello phone. What are you doing, phone? this is the iPhone, and it's deciding to, like, move around without me moving. That's really, really weird.
Is it trying to focus on something? Is that?
I really don't understand what the iPhone's doing, but yeah. So here's one wavetable, different wavetable, another wavetable.
That's great.
And so anyway, well, that's really kind of nauseating. Let's turn that off.
So wait, was that the camera trying to do some tracking on its own?
I think so. Yeah, I was using the, like, use your iPhone as a camera
trying to find
thing.
a subject.
Yeah, and I think as soon as I put my hands in there, it was like, flesh thing.
Yeah, follow the flesh. Thanks, Apple. Thanks, Tim.
But yeah, so I'll put the link to this. It's hosted on GitHub.io.
Great.
I've got up to basically section 4 done.
Yeah.
There's going to be about like 50 or so different fully working code snippets. Each one is pretty interesting sonically, and then I'm just now addressing the audio effects one, which is really exciting because now we can do, like, chorus and delay and pitch shift and reverb and all that kind of stuff. And yeah, so but my favorite thing about Synthio is the fact you can change all the waveforms, so you can make any of these waveforms be an oscillator for your synth. So yeah. Great.
Yeah, I know you're a wavetable synth fan, going way back, right? But it's
very much, yeah.
That's great. So can you put a link in the
chat,
so people can go find it? Yeah, we're in the chat. That would be great. And we'll probably post a little blog post whenever you want to get the word out. I'll post something up on the Adafruit blog so that people can go find it and play with it. I'm excited about this because I've used Synthio for a while too. And is it really 2 years? That's insane.
I think even more than that.
Oh my god! But I would love to dive into this as like a refresh on how, like, the building blocks of it work and how all the little pieces work. So.
Yeah, my main sort of, like, destination for this whole thing is to create a set of classes that sort of are a synthesizer with the various knobs and buttons you'd expect on a normal synthesizer. The Synthio has some of that, but not all of that, because it doesn't really implement every feature you'd want in an actual synthesizer. So you have to kind of write code on top of Synthio to do that. And it turns out that Cooper has already written a couple of classes that do a lot of this. So if you want to get started right now on something much higher level, you can use his classes. I've linked those on the first page of the tutorial. But I kind of wanted to go do it and have my version of what am concerned about in my version of the classes. So, so they'll be a little different, but they'll address a lot of the same topics.
Yeah. Oh, really cool.
Thanks.
Thanks so much for bringing that on, Todd. All right. Hey, thank you everyone for bringing by your cool stuff, and thanks for coming by to watch and hang out over in our chats. Like I said, we do not have Ask an Engineer immediately following this, which we often do, but there is a pretty good chance that Limor and Phil will be putting together a pre-recorded Ask an Engineer, which will air later. So keep an eye on the blog, keep an eye on the Discord, and we'll see when that comes out, and you can check that out. Of course, it'll be up on YouTube. You can watch it at any time. But if you want to see it when it breaks, when the breaking news breaks, then keep an eye out, and we'll let you know when that posts. Thank you everyone so much. I'll be on tomorrow in the afternoon, 4 o'clock Eastern time, with my workshop show. If you want to come by and see some stuff, I'll give you a little sneak peek. I've got some work going on my little mini computer space arcade. So come on by. Thanks everyone so much. And I will see you soon. Bye-bye.